Okay, here is the solutions for the mock exam for lines. In problem 1, it gives us several line gradients in several different forms. I think the easiest way to see if these line gradients are the same or not is to change them to similar formats. So maybe you could change them all to decimals, or you could change them all to fractions. So I'll show you how to do that with the calculator. If you want to change things to fractions, there is a command to do that. So like, for example, let's see, 0.5. If I want to change 0.5 to a fraction, I do 0.5 and then I go to math, and then do you see the first option is already like arrow fraction, so you just change this to 1/2. So I can find out that 0.5 is 1/2. 0.4, I could do the same thing. I could go 0.4 math number 1. I'm sorry, not 24, 0.4. 0.4 math, enter. 2/5. Okay. And if you want to do the opposite, it's a lot easier. You just do, like, if I want to change 5/2 to a decimal, I just put 5 divided by 2, I get 2.5. So negative 5/2 would be negative 2.5, for example. Okay. 3/6, if I did this in the calculator, it would give me 1.5, right? 0.5. Okay, so 0.5. Negative 2.5, 2 divided by 5 is 0.4, so negative 0.4. And finally, 5/2 we already know is 2.5, so 5 divided by negative 2 would be negative 2.5 also. So now that we have everything changed into decimals and to fractions, I can like match up stuff, right? So I'm looking for pairs of lines that are parallel to each other, so those would have the same gradient, right? So for example, negative 2.5 is the same as negative 2.5. And is there any other pair that is the same? 0.5 and 0.5. So there's at least two pairs. There's B and G, and there is D and E. Those two pairs are the same. B and G are both negative 2.5, and D and E are both 0.5, right? Next problem is find any two pairs of lines that are at right angles to each other. Remember, if they're at right angles to each other, that means they're perpendicular. We use this symbol to indicate perpendicular. And if they're perpendicular, they're at 90 degrees, and that means that their gradients are negative reciprocals of each other. So in this particular case, maybe it would be easier to use the fraction symbols, but you can still figure it out. Like, for example, if I say, let's start out with the easy ones. So like A and C, do you see how these are negative reciprocals? Because negative 3 by itself is actually the same as negative 3 over 1. That is the negative reciprocal of 1/3, right? Because 1/3, if you turn it over, is 3 over 1, and the negative reciprocal of that would be negative 3 over 1. So these two are a pair. So A plus C are a perpendicular pair. What about negative 2.5? What would be the negative inverse of negative 2.5? The way we can find it is we do negative 1 divided by negative 2.5. Gives us 0.4. Oh, 0.4. There's another line here that has a slope of 0.4. It's H. So I could also say B and H. And what else? 1/3. We already have 1/3. It's the negative reciprocal of negative 3 over 1. What about 1/2? Is the negative reciprocal of 1/2 would be negative 2, right? But there's nothing with negative 2. This is also 1/2, so we already know there's no negative reciprocal of 1/2 here. What about negative 0.4? The negative reciprocal of negative 0.4 would be positive 2.5, right? So 1 divided by negative 0.4. Oh, actually, we need the negative reciprocal. So we'll do negative 1 divided by the negative of 0.4. It's equal to positive 2.5. And, oh, that would be, oh, there is no positive 2.5. Okay, so this doesn't have any negative reciprocal pair. Negative 2.5 is the same as B, so G would also be a negative reciprocal pair of H, so G plus H. Okay, all right. So any two pairs, so you could give me just 2 of these 3 pairs, and that would be fine. Next, number 2. The following diagrams show 6 lines with equations of the form y equals mx plus c. When we look at these different lines, remember what we talked about how you can just look at a line and you already know if the slope is positive or negative, right? So let's see. We'll classify each one of these with a positive or negative slope. Whenever I see a line going down, that is a negative slope. So these 2 are negative slopes. So m is less than 0. M is less than 0. The slope is negative. Oh, this one too. M is less than 0. For the others, m is greater than 0, right? Oops. M is greater than 0. M is greater than 0. M is greater than 0. What about the y-intercept? So the y-intercept for this one is negative, right? So I'm going to say C, the y-intercept, is less than 0. Here the C is greater than 0. Here the C is 0. Here the C is greater than 0. Here the C is less than 0. And here again the C is equal to 0. Okay. Now that we've classified each one of these in terms of m and c, let's go down and look at the bottom. M is greater than 0 and c is greater than 0. Which one has m is greater than 0 and c is greater than 0? Looks like L5. What about m is less than 0 and c is greater than 0? M is less than 0 and c is greater than 0. Looks like this one, L4. Right? M is less than 0 and c is greater than 0. Okay. What about the third one? M is less than 0 and c is less than 0. That would be L1. L1. And what about m is greater than 0 and c is less than 0? That would be L3. L3. Okay? So the other 2 are just left over because there is no c equals 0 in this these conditions, right? And that's the end of this one. So let's go to the next page. Number 3. A student has drawn the 2 straight line graphs, L1 and L2, and marked in the angle between them as a right angle as shown below. The student has drawn one of the lines incorrectly. Consider L1 with the equation 2x plus 2 and L2 with the equation negative 1/4 x plus 1. So how would we graph these? Well, remember that the first number that is multiplied times x is the gradient. And the second number, which is just added without any x multiplied times it, is the y-intercept. So let's check to see if these 2 lines are actually graphed according to the equations. So if I was going to graph 2x plus 2, I would have a y-intercept of 2, and I would have a slope of 2. Is this slope 2? Let's see. I'm going to draw a red triangle underneath this line. I have a rise of 2 and a run of 1. So that would be 2 over 1. Okay? And the y-intercept is 2. So that looks perfectly fine. This really is y equals 2x plus 2. Okay? All right. What about the other one? The other one says a y-intercept of 1, which it indeed has. Then we check the slope. Is the slope negative 1/4? A negative 1/4 slope would be a rise of negative 1, so it means goes down 1, and a run of 4, so it goes across 4. Now, if I had a rise of -1 and a run of 4, it would look like that, right? Because it would be 1 tall and 4 wide. And obviously, this line is not that angle. So my second equation, which is L2, is incorrect. So if I really wanted to draw it correctly, it would look like that, right? And this other one here is L1. Okay. Write down the gradients of L1 and L2 using the given equations. So L1 has a slope of 2, and L2 has a slope of -1/4, as we noticed above. Which of the two lines is drawn incorrectly? Line 2. Can you tell from the answer to part A that the angle between L1 and L2 should not be 90 degrees? Yes, because 2 is not the negative reciprocal of -1/4. So they can't be, right? If it was 2 and -1/2 or 4 and -1/2, then it would be fine. Draw the correct version of the incorrectly drawn line. We just did that. It's this one right here, right? Okay? Next page. Number 4. The equation of the line R1 is 2x plus y minus 8 equals 0. The line R2 is perpendicular to R1. Okay. Now, this, of course, is not gradient intercept form. It is standard form. And standard form, remember, is kind of useless. It doesn't show us the gradient. So, at least not easily. So what we need to do to see the gradient is we need to rearrange this form into gradient intercept form, which looks like that, remember? So let's take R1's equation, 2x plus y minus 8 equals 0, and let's rearrange it so that y is on the left by itself. So first thing we're going to do is we're going to subtract 2x from both sides, and then we get y minus 8 equals -2x. Then we add 8 to both sides, and then we get y equals -2x plus 8. So this is the equation for R1. Then it says R2 is perpendicular to L1, and to calculate the gradient of R2. Well, what's the gradient of R1, which is perpendicular to R2? It's -2. So R2's gradient should be the negative inverse of the R1 gradient, and the R1 gradient is -2. So it should be -1 divided by -2, which is +1/2. So the gradient is +1/2. The point of intersection of R1 and R2 is 4, something. Find the value of K. Okay, well, we don't know where R2 is in relation to R1. We only know that it's perpendicular, but if the point of intersection of the two is 4, something, all we need to do is figure out what is the coordinate of R1 at 4, something, and then that would give us the coordinate also of R2 because there's an intersection there, right? So let's do that. We're going to turn on the calculator, and then we'll go to y equals, and then we're going to program in the equation for R1. R1 equation, we don't want to use this original equation because we can't put that in the calculator. We're going to use the new equation that we calculated, -2x plus 8. So -2x plus 8, and then we're going to look at the table, and the table tells us many points, but look, it tells us the ordered pair 4, something. So the ordered pair 4, something actually is 4, 0. So the value for the y value that corresponds to x equals 4 is 0. Okay, so it's 0. Then what they want to know is they want to know the equation of R2. Okay, and the only thing we know about R2 so far is that the slope is 1/2. Do we know anything else about the slope? Or do we know anything else about the line? Well, we do know that it goes through the point 4, 0. Okay, so if we graphed it, let's solve this by graphing first. So 1, 2, 3, 4, comma 0. That's one of the points. And it has a slope of 1/2. If it has a slope of 1/2, that means the rise is 1 and the run is 2. So on this map here, or this grid here, it would be 2 run, and then it would be 1 rise. And then I can use these 2 points, which are 4, 0 and 6, 1. I can use these 2 points to figure out what the equation of the line of R2 is. So the way I do that is I do linreg. So I go stat edit, and then I put in these 2 points, which are 4, 0 and 6, 1. And I'm going to do stat calc linreg. And the equation of the line is going to be y equals 0.5x minus 2. That's the equation of that line. And I think that's the last one.